In this session, we will be discussing about another flavor of CPU scheduling algorithm, which is longest job first. So this is a completely different from shortest job first. So in this case, longest burst time is going to be executed. Now, again, there may be a conflict among the burst times. If at all burst times of the jobs are same, then we need to choose a what? Lowest arrival time. So in this case, at arrival time 0, all the processes have entered into the ready queue by name P1, P2, P3, P4 and P5. So now we want to choose longest job first. So among these 5, which is having the longest burst time? P4. So P4 is executed. And P4 is executed 6 units of time of CPU, then it's get completed. Then after rest of the process are P1, P2, P3, P4. P4 is already completed, P5 is there. So among them, which is having the longest burst time? P3. So P3 is delivered and it is executed 5 units of time, by 11 it completed. Then the rest of the process, now P3 is completed, P4 is completed. So among this and this and this, which is having the longest burst time, P1 is having. So P1 is executed for 4 units of time, 15 it got completed, and the rest of the process are left over this and this. So P2 is eligible this time because its burst time is more, and by 18 it completed. And the last process, which is having the P5, so P5 get executed 2 units of time, by 20 it get completed, and this is completed at 18. So you can easily compute turnaround time and waiting time. Don't forget that, which is nothing but a what? CT minus AT, and this is nothing but a what? Turnaround time minus how much time you spent with the CPU. So let us see a different variety. There is a process number 1, 2, 3 and 4, and arrival times are 0, 1, 2, 3, and burst times are something like 5 and 5 and 5 and 5. Now want to solve using a what? Longest job first. So let us take the Gantt chart. There are 4 processes. At time 0, there is no other process is there. There is no chance to that. So P1 get executed 5 units of time. And during 5 execution by P1, during this 5 units of time, the other process have come. One has at 1, the other one has at 2, other one has at 3. Their arrival times. So P2 is there, and P3 is there, and P4 is there. So among these 3, you understand which is having the longest burst time? No, because their burst times are same. Whenever processes burst times are same, then what I said, we need to choose a what? Lowest arrival time job, which is nothing but this guy. So P2 is executed for another 5 units of time. Then rest of the process P3 and P4, their burst times are also same because 5 and 5. They need to choose the lowest arrival time job, that is nothing but a P3, and afterwards the last job is P4. So this is how to solve if at all burst times are what? Same. So let us do this. So at arrival time 0, there is only one process is arrived, P1. So P1 is executed for 3 units of time, by 3 it completed. And the duration of 0 to 3, how many processes have come to the ready queue? Only 3 processes have come, P2, P3 and P4. Among these 3, which is having the longest burst time? So this guy is having a longest burst time, P4 is executed for 5 units of time, 8 it get completed. Then during execution of this P4, one more process is also dropped. So that is nothing but P5. It is arrived at 4. And now what happened among these three, which is having the longest burst time? Among 2, 3 and 5. Among 2, 3 and 5, which is having the longest burst time, P5. Though he has arrived later than other processors, but he is given a preference because longest burst time. So P5 is executed for 6 units of time, 14 is got completed. Then the rest of the process V is having a longest burst time, P3 is having a longest burst time, is executed for 4. And the only one process P2, though he has come arrival at time 1, he has given a preference lost. So it is executed like this. So it is at this and this is at this. The remaining process, So this is how to perform longest job burst time.